So we saw that subtraction and addition are related, especially once we throw sign numbers in there, these new relationships pop up, like 7 plus -3 seems to give us the same answer as 7 minus 3. So there's that relationship there. So we got to explore subtraction more to explore that relationship. Now, subtraction isn't addition. It's not, right? It's something totally different. What is subtraction? Well, one, either we looked at subtraction as takeaway, or two, we looked at subtraction as a comparison. Now, that's subtraction. Now we have the idea of integers to combine with that. And integers, we're going to use our charged particles. So I'll have a key up here for that. So charged particles. And our key is that a plus is a 1, a minus is a -1, and 0 is either nothing or the combination of a plus and a minus together. And so that could be 0. So what does it look like to do a takeaway? Well, if it's just whole numbers being subtracted, it's no different than before. So 7 minus 3 would look like this. 7 minus 3 means start with 7, then take away 3. Okay, so step 1, start with 7. 1, 2, 3, 4, 5, 6, 7. And then we're going to take 3. So I had 1, 2, 3, 4, 5, 6, 7, but I am going to take this one and that one and that one, and they're gone, and that leaves 4. Right, positive 4. So I'm just doing it with pluses this time. We did it with other things before. What if I try to do something like, how about 4 take away, let's draw a little line in between here, 4 take away 7. All right, so that means start with 4, then take away 7. So again, that means start with 4, then take away. And prior with kids, we realized, like, well, how can you take away 7 if you only have 4? Right? You can't do that. But now we have negative numbers, so we can do it. And my key is going to help me do it. So I'm going to, just like before, I'm going to start with 4. So here's 1, 2, 3, 4. Now I want to take 7 positive. That's what this says. From 4, take positive 7. Don't got positive 7 there. So we have to rewrite this. So rewrite 4. How do we do that? Well, earlier we realized that if we have some zeros present in the set, they don't really count. Here's what I'm going to do. Let's say here's my original 4 right there. I'm going to start putting some zeros in till I can take away 7. So this set right here is still 4 because the plus and the minus are 0. This set right here is still a 4 because the plus and the minus are 0. And this set right here is still a 4 net charge because a plus and a minus is 0. So this set right here is still 4, but now I can take 7 away. So I just rewrite the set so that I can take what I want. So now I can, take 7. So I'm just going to rewrite this one more time. I had those 1, 2, 3, 4 there. And then I added some zeros so that I could find 7 positives to take away. And now I'm going to take them away. I'm going to take this one, and this one, and this one, and this one, and that one, and that one, and that one. Those guys are gone. And now I can see that leaves -3 behind. So 4 minus 7 must be -3. And I had to do it with takeaway because subtraction means takeaway. Now I could do a comparison. That's a whole nother thing. How does 4 compare with -7? That one's a little harder with the charged particles. I think the takeaway is way easier to do. We'll try a comparison next just to see. So again, with the takeaway, if you can't take what you want, you rewrite some zeros until you can. Now, alternatively, I could have put more zeros in there. So I could have had a set that looked like this. 1, 2, 3, 4, and then add as many zeros as you want. Doesn't matter how many, as long as it's more than enough. So this set right here, oops, my negative is in the wrong direction. This set right here is still a 4 until I start taking stuff away, and then I just start taking, my 7 away. So I would take away, say, this one here, and that one there, and that one there. So 1, 2, 3, 4, 5, 6, 7, and then I got to figure out what's left. Okay. Well, I see pluses and minuses on the same screen, and when I do that, I can combine and make some zeros. So this one and this one make a 0. This one and this one make a 0. This one and this one make a 0. So I'm not taking those away. I'm just identifying them as I have some zeros here. And I took 7. That still leaves -3. Who cares if the zeros are there? But I have to put at least 3 zeros in to take 7 from 4. All right, how does comparison work? Four minus 7. So what I want to do is I have to compare the whole first number, the whole second number with the first number. So I have to see 7 here to do that comparison. So at first, when I try to do that, 1, 2, 3, 4, and then I compare to 1, 2, 3, 4, 5, 6, 7, I can't quite make that comparison, right? The comparison really goes back that way. If you're not sure what I mean by that, think about a simpler example, like 7 minus 4. Let's go the other way. That one right there says start with 7. 1, 2, 3, 4, 5, 6, 7. And I want to compare to 4. 1, 2, 3, 4. In the past, what we did is you say, okay, this one right here matches up with that one. This one right here matches up with that one. This matches up with that. This matches up with that. I'm done with the number I'm comparing to 7, and that leaves 3. All right, so I have to account for that whole second number to do subtraction. That's how we did comparisons before. Now, in this case, when I start that comparison, I'm incomplete. I match those up right there. And at this point here, I'm not done. My comparison is incomplete. Incomplete. I didn't finish the subtraction as comparison. So what I have to do, because that's incomplete, is I got to rebuild this. Rebuild to compare. So then I would take my 4 and I would write it as 4 with some zeros. How many zeros? Just enough. So I could add a 0 and another 0 and another 0. Oops. Right, this is still 4. I want to compare that to 7. 1, 2, 3, 4, 5, 6, 7. And now I can complete the comparison. So this one lines up with that one, and that one, and those two, and those two, and so on, till I'm completely done with the second number. And I can see that leaves -3. So the comparison's a little weirder. I really like with the showing kids what it means to subtract integers. I think the takeaway is way easier to think about. But the comparison's kind of like the addition, where a lot of times with the addition, we had to rebuild, or we had to combine and get those zeros. And in this case, we definitely have to rebuild. But I think the rebuild makes more sense when we can say, hey, I don't have enough to take away. So the takeaway feels more intuitive to me. And I think that's true for most kids too. So that's the chip model or charged particle model for the subtraction of integers.